Alrighty, hey guys, our next video is the next page in our notes that we've been working on about sector area. So right now I'm back on this page right here, so we can define what a sector is and what sector area is. So the good news is it's really a lot like the arc length stuff we did last class. So if you felt good about the arc length practice that we did, you're going to be in pretty good shape for this sector area. So the only difference is, instead of being a part of the circumference like we looked at here, a sector is a chunk or a portion of the area. So you can see the difference between these two diagrams. Sector area is area inside the circle. Arc length is part of the circumference. So the area of a sector is a portion of the total area of the circle. So we're going to solve it the same way using our proportions, but instead of using the circumference formula like we did out there, we're going to use the area formula, which is pi r squared. All right, so skip ahead a couple pages. We are up to here. So practice with sector area. So go ahead and find that page. And I think what I talked about in class really helps some people visualize this. So if I just draw a circle right here, and there's my center, and I make a nice 90-degree angle. So if I make that a 90, we know this sector, 90-degree sector, is exactly 1/4 of the whole circle. So let's just say, I'm just making up some numbers here. Let's say this radius is 2 centimeters. The area of the circle would be pi r squared. All right, so you don't have to write all this, but I'm just kind of showing you how this works. That shouldn't be a negative there. There we go. So the area of this circle would be pi r squared, which would be 4 pi. All right, you guys with me there? So the area of this whole circle would be 4 pi. But remember, if I'm just looking for the area of just this sector, and the number I gave you was a 90-degree angle here, we know 90 degrees is exactly 1/4 of 360. So that's where the proportion comes into play. So if I'm looking at the area of just this sector, if the whole circle is 4 pi, that means each sector would be 1 pi. So that's where these proportions work. So if I think about 90 degrees as a quarter of my circle, that means each of these areas, each of those quarters would be 1 pi in that case. Okay, so it's the same formula. So we're looking at this today. It's the central angle over 360, or as we talked about, if it's in radians, it'd be over 2 pi, depending on what they give you, equals the sector area, and this is usually our unknown, so we'll call that x, over the total area. So you will have to make sure you memorize that pi r squared formula. So let's see how it works. Find the area of the shaded region. So here's what we're looking for, the area of that chunk right there. So we have our central angle is 100 degrees. So we know this 100 degrees is a portion of the whole circle. So like, I showed you last time, this 100 is a portion of this 360 so equals the portion of my area, there's our unknown, is to the area of the whole circle. So the area of this whole circle is pi r squared, pi times 6 squared. So 6 squared is 36, so my area is 36 pi. So 100 degrees is to 360, part over whole, as part of my area is to the whole area. So the same exact thing we've been doing, except the only thing that's different is the 36 pi is pi r squared. So we cross multiply. We get 360x equals, and this is going to come out to be 3600 600 pi, so leave the pi out of it for now. And pretty quick and easy to get x by itself. We'll divide by 360. Final answer, 3,600 divided by 360 is just 10 pi. And then whatever our units are, centimeters or inches or whatever, it's always going to be units squared because we're talking about area. And there's the math. 10 pi units squared. Done. So if you want to try the next one on your own, I'm going to do letter A, so you can pause and try it on your own. If you want to walk through it with me, I will. But again, we have a portion of the circle. So we have our 60 degrees is to 360. 60 is to 360 as our chunk of our area, x, is to the entire area. So area, again, is pi r squared. So the radius is 5. So this is total area is 25 pi. Do a little bit of math. So you will need your fraction button again for this. So we have 360x equals, and I'll give you 25 times 60 is 1,500 pi. Ooh, I forgot my x here. Hopefully you guys caught that. 360x. So to finish it up, I divide both sides by 360 again. Divide both sides by 360, and I get x equals, and if you do use your math frac button, it's going to come out to be 25 pi over 6 centimeters squared. So as you can see, it's all about getting that equation set up the right way. All right. As we did the very last question in class, if you do have different pieces of information, let's say I want you to find the angle instead of the sector, you can do the same thing. You're just going to set up the proportions just based on what you know. All right, so last one, letter B. Now, here's the big difference. Now we have radians again. So a couple of students suggested, well, can I just convert radians to degrees? That is a great way to do it. You can just convert that right to degrees and just use 360s. But if you want to keep it as radians, the first part of your equation, this is where you need to be careful. So I know pi over 3 radians. Now that doesn't match up with 360. That matches up with 2 pi. That's the whole circle in terms of radians. So pi over 3 is to 2 pi, as my unknown sector area is to the entire area of the circle. And we have 5 again here. So pi r squared. We have our 25 pi again. And the shortcut I showed you in class last time, I know I'm going quickly, but pause if you need to. The shortcut I showed you in class last time, which is really, really helpful, those pi's cancel out. They reduce down. And all we're left with here is a 1 over 3. So we cross multiply. 2 times x, we can do that. And here's where you have to be careful. It's the entire term there, the entire 1/3 times 25 pi. All right, a little bit of algebra. You know, you can do 1/3 times 25 pi. You can divide both sides by 2 first. But either way, if you have your calculator in front of you, you know, we're going to end up dividing by 2. This will finish up. And actually, it's going to be the same as the question before. Because if you convert pi over 3 to degrees, it's going to be 60. So we have x equals 25 pi over 6 centimeters squared. So the radians are more difficult. It's really, really helpful to have your calculator there. But it's the same idea, except now we're dealing with area instead of circumference. So that's all. You have another 2-question online homework check. And good luck. And I'll see you in class. Bye.